Hi, I hope you all had a great Christmas break. So I think this is actually a fun lesson that we're going to have today. It's called Summing It Up with Sigma. And Sigma, here we're talking about the Greek letter Sigma, the capital letter. Could make it look a little better. Not the lowercase letter, which looks kind of like that. But this capital letter, which you see a lot around college campuses. So let's learn how we're going to use the sigma notation. First off, I'm going to tell you a little story real quick about a mathematician called Carl Friedrich Gauss. He was a German mathematician, lived 1777 to 1855, and he was a mathematical genius. And so he was in his classroom, according to the story that I found, and he was 7 years old. And his teacher was trying to give all the kids math problems to work on. And, he's a little math kid that loves math and works his problem, runs back up to the teacher, and the teacher has to find something else for the kid to do. So they come up with another problem for him to do. And he runs back to his seat, works it out, and runs back up. So the teacher thought, I'm going to buy myself a little time. And he told Carl, I want you to sit down and I want you to add up all the numbers from 1 all the way to 100. And Carl's like, oh, okay. So he goes and sits down. And within just a couple of minutes, he's back up at his teacher's desk with the problem solved and with the right answer. And his teacher was just astounded. And this is what he did. So in class, normally I like to give you all a few minutes to try to think about what you would do. So if you want to pause the video and think about how you'd get the answer really fast, go ahead. I figure most of you did not pause the video. So what he did was he realized if I add the first number and the last number, I get 101. And if I work my way in like that, 2 and 99, 101. 3 and 98, 101. So if you keep going that way, 4 and 97, 101. The sum is always 101. And he thought, I'm going to get 101 each time. How many pairs of this 101 am I going to get? Well, there's 100 numbers, and he's adding up 2 each time, so there would be 50 pairs. So he said 101 times 50 is 5,050, and he went out and showed his teacher his answer, and he was right. So this is just a little introduction of sigma notation, also called summation notation. I'll put also known as summation notation. Kind of fun to say a few times. Is when we use this Greek letter sigma, and we use a variable. Lots of times it's I. Let me go to the next page. So summation notation uses this Greek letter sigma. So if you see this Greek letter sigma, you know you're going to sum or add a bunch of things up. And usually we use an I at the bottom. 1 tells me the first number I'm going to start with. And let's say we go to 6. That's the last number we're going to go to. And let's say we're going to do I squared. So this is your function, f of x. Let's say f of x was I squared. And so we want to add up all the numbers from 1 to 6. All the answers. And it's just a really concise way to write this. And so I'm going to rewrite it down here to give myself a little room. All you do, it's like a factory or it's like a machine. We're going to put a 1 in to the function and see what we get. So when you put 1 in to this function right here, you get 1 squared. Plus, because this is a sum, summation notation, sigma notation, then you go to 2. Plug 2 into I squared and you get 2 squared. We're going to plug in every number from 1 until we get to 6. And once we've done 6, we'll stop. So we've done 1 and then 2 squared. Next we'll do 3 squared. Next we'll do 4 squared, 5 squared, 6 squared, and we stop. So it told us the first number we were going to plug in was 1. The last number we were going to plug in was 6. And then we will just add all those together. We got 1 plus 4 plus 9 plus 16 plus 25 plus 36. Let's see if Carl Friedrich Gauss's strategy will work here. Oh, no, it doesn't. And then we get 25. Let's see, what's that? It's been too long since I've done math. I think it's 91. I think that's right. So that is how summation notation or sigma notation works. Let's say you've got a problem, I equals 1 to 4, of some function f of x, and you get this, and they want you to figure out what the function was to start with. So you look at it and you say, okay, I'm adding a bunch of things up. I'm adding 1, 2, 3, 4 things. So 1, 2, 3, 4. Every one of these terms has a 3 in it. And the thing that's changing, this one's weird, but right here, this is the number that's changing. Like plug in the 2, plug in the 3, plug in the 4. So that's my variable. That's my I. But does it work for this? Yeah, we can write 3 as 3 times 1, and then that works for me plugging that 1 in to start with. So f of x is 3i. Let's see, let's do another summation notation. I equals, doesn't have to start at 1, it can start at 3 and go to 7. And let's say I want to plug into the formula 4i minus 1 over 5. They're going to be terrible, nasty. All right, so we're going to plug in a 3 to start with, and then 4, 5, 6, and stop when we plug in 7. So we've got 4 times 3 minus 1 over 5 plus 4 times 4 minus 1 over 5 plus 4 times 5 minus 1 over 5 plus 4 times 6 minus 1 over 5 plus 4 times 7 minus 1 over 5. I don't guess we'll actually work that out. I just wanted you to see how to plug in things and how summation notation works. I'll be happy to answer some questions in class Wednesday if you all have some questions on it. I'm not sure if I'm going to be able to post the assignment yet, but it's the review and preview problems 3-88. Oh, let me back up and get 3-87 and 3-89. Those are the only ones that I want you to try for me for tonight. All right. Good luck. I look forward to seeing you all on Wednesday.